Okay. So when you have two equations together like this is what we call a math system of equations. Basically, I've got these two equations, and each one of them represents a pattern, and I want to see how they stack up against each other or how they compare to each other. And what I told you guys a minute ago is that one of the best ways to do that, and we'll learn some other ways too, is to put them on a graph, because a graph gives you a nice visual of the pattern so you could kind of see what's going on. These are both in slope-intercept form, which means we just need to get them onto the graph. And this is something that we've talked about how to do. So we're going to see if we could get a couple of volunteers to help us with getting this on the graph. Sam. Okay, this top equation. What's my start value?
2, -2.
-2. And where does start value always go?
On the left side, on the y-axis.
On the y-axis, right. So I'm going to put -2 on the y-axis because that's my start value for this. Yeah. Okay, so Sam, now what does this tell me to do?
Now, since it's rise and run is the x, so you do up 1, across 2.
Perfect. Up 1 and across 2. So if we do that, and I'm going to do that a couple of times just so we can see really well where our line goes.
And as you can see, it's a positive correlation.
Okay. There's 1, right? Now, I'm going to take the second one, and we're going to put it on the same graph. Because if you put them together on the same graph, it's a lot easier to compare them. If you put them on separate graphs, it's harder to compare them because you're trying to look back and forth, and it's harder to see kind of where things match up and where they don't. So it's better to put them on the same graph if you're trying to compare.
What if the lines overlap on each other?
Okay. Let's see. I've got a couple of people that I know are still working on.
Why do you have to mark 3, not just 2?
Brady.
Yeah. Okay, so our start value is 5.
Okay. And Sam just told us that always goes on the y-axis. 1, 2, 3, 4, 5. So I'm going to be like way up there, but that's going to be okay because, Brady, what's going to happen with my slope? Yeah, my slope's going to take me down because it's negative. So talk to me about rise and run. How do I know where to go?
So usually what I do, I just put a 1 underneath -3. So then you go down 3, then over 1.
Yeah, exactly. So when I have a whole number, I can make that over 1. So down 3 and over 1. So Brady's right. Down 3 and over 1.
Why do you have to?
So my other one's going to end up going like that, right?
Why do you have to draw 3 dots, not just like 1?
Well, the dots are just telling you where you're going to land with your rise and your run.
I know, but like, why not just 2? Why 3?
There's kind of an unspoken rule. You're right. Technically, you only need 2 points to draw the line. But it's a good idea to do a third point as kind of an error check just to make sure you counted right. You know, what if I meant to count 3, but I accidentally only counted 2 the first time? When I do it again, I'll see, oh, the points don't line up. Oops, I miscounted. So it's a good idea to do a third point just to kind of check your work and make sure you counted right. Okay, what do you guys notice about how these compare?
They cross at
They don't even look the same.
They cross, exactly. So I've got one pattern going up and one pattern going down.
They made a triangle.
They cross. What do you think's happening right there where they cross?
That's where that's where they
intersect.
have a similarity.
They intersect. What's happening with the pattern? Like if I wrote out the numbers in both patterns, what would be happening right there?
Would be the same.
Yeah, they would be the same. So there's a point in the patterns where the patterns are going to match up. If I had listed out the numbers in the pattern, when I got to that point in the pattern, they would have the exact same numbers. Okay. I like that you guys picked up on that intersection point because that intersection point is actually important. In math, we talk about solving a system of equations. And when you solve a system of equations, what it's asking you to do is to find that intersection point. That intersection point is important because it's a place where both patterns are the same. And if you're trying to compare things, it really helps to find where things are the same. So this, I'm going to highlight it, and this is something that we'll talk more about tomorrow too. But that intersection point, that's what we would call a solution to a system of equations. That's a solution. How many times are these lines going to cross?
Once.
Yeah, if I'm running straight lines, they can only cross one time, right? So I would say something like this has one solution. So that's one type of relationship that these could have is I've got a couple lines that they cross, which means they have one answer. Rewinding this a little bit. We'll talk more about the actual answer tomorrow. Right now we're just looking at what are the different things that can happen. I could have known without graphing this that they were going to have one answer. What clues do I have just by looking at the equations that those are going to cross? Rachel?
One's positive and one's negative.
Yeah, the slopes are opposite. If you have one going up and you have one going down, they're going to cross, right? What other clues do I have?
The starting values, one's positive, one's negative.
Yeah. Well, and you have to be careful with that because they could have the same starting value and it just means they cross at the starting value. What if I had y equals 2x and y equals 4x? Those are both positive. Are they going to cross?
Oh yeah, they
only
will.
one
They will.
solution.
They do at 8.
If I have 2x and 4x.
Oh, because it depends on where the slope.
Well, they're both going up. But one's going up with a slope of 2 and one's going up with a slope of 4.
So they basically need to be divisible by each other. So like 4 divided by 2 is 2. So like they would intersect at 4, 8, and 12. It's like basically any multiple of 4.
Yeah. And another way to think of this visually too, if I want the lines to cross, they have to be going different directions, right? So we already picked up on the fact that on this one it's obvious because one's going up and one's going down. So if you have one going up and one going down, they're very obviously going to cross each other. I can have two lines that both go up and still cross. They just have to not be the same steepness, right? So if I have one line that's really, really steep and maybe another one that's going up but not as steep, they'll eventually cross, right? And what controls the steepness of the line? The slope.
Oh, the rise and the line.
Yeah.
It's basically the fraction.
So as long as the steepnesses are different, which is controlled by the rise and the run, then I know they're going to cross, right? So I could actually have told that they were going to cross just by looking at this, because if you look, this has one slope and this has a different slope. They have different slopes. Anything with different slopes means that the lines have different steepnesses, which means they're going to cross somewhere because they're going at different angles. So that's kind of the big giveaway for your, yeah, you're going to have lines that cross. Slopes are going to be different.